There we go. I think that'll do it. If you're here, let me know in the chat. Cool. So, um, as I was saying, and you couldn't hear me, this is Code with me, and for the time being, this is going to be USD with me because I'll be showing you different things about universal scene description, about how to use the Python API to author USD, query it, do all the work you would need to do with USD, and I'll be doing just small examples that will build up to larger concepts. So the last couple of weeks we were talking about materials and how to build a USD preview surface material using Python API, and then we talked about um, how to build a USD material so that you could have shader graphs for specific for different renderers, but all of them plugging into the same material. So you just assign the material once, and it works for different renderers, whatever context you're in. So those were the previous live streams. If you haven't checked those out, go ahead and search them on our NVIDIA Omniverse channel. And today we're going to be talking about variant sets. So we're going to be creating some simple examples of variant sets and exploring what can you do with variant sets, at least the basic examples, and we can talk about those a bit. This is totally exploratory. Feel free to ask any questions you may have about variant sets in general or things that I'm doing at the moment. If you haven't joined our NVIDIA Omniverse community, I highly encourage you to check out this channel here. And um, and what you can do here is we have this become an Omniverse Insider link, which takes you to a form, and you can fill that out. Uh, Fill out as much as you want. It's a fairly lengthy form. Fill out as much as you want, and then you can come back and fill out more or edit the information. Basically, it's just information about you, social media handles, and what you're working on, what expertise you have in certain applications. That way, we get to know you better. We know who's out there in our community that is an expert in certain applications. So when um, opportunities come for focus groups or early previews, we know who we can reach out to for that. And then also sometimes we have customers and partners that are looking for people with certain expertise that they want to hire, they want to work with for a temporary time, and so we'd love to be able to connect people from our community for that. So yeah, link is there. And this is a link to the Omniverse Code With Me repository, where you will be able to find the code that I'm working on today. Here is in the scripts folder are the previous two, and I'll have the new one in there as well. So that's it for the preamble. If you're here in the chat, let me know. Say hi. We had a pretty long weekend this weekend. We had some NVIDIA days off on Thursday, Friday, and then Monday was Juneteenth here in the US. So it was a pretty great rest, and so I'm ready to dive into variant sets. So there is a great tutorial from Pixar about authoring variant sets here. If you haven't tried it out, hey Ashley, if you haven't tried it out, that is a good place to start and try something for yourself after this. You can just walk through here. It gives you step-by-step code blocks for building up a shading variant. And we'll be doing much of the same here on the live stream, and then also doing some other examples. And then we also have our variant set snippets here that we shared from NVIDIA. And these are just great refreshers for when you're ready to write some code for variant sets. You're probably going to want to remember, okay, how do I create a variant set? How do I select a variant of a variant set? And then how do I author data within a particular variant set? So we'll be looking at all three of these today. And that's it. So let's do it. Here is my code, and here's my code. This is Omniverse code where we'll be exploring and we'll be looking at the work that we're doing, and we'll be writing our USD code in here. So most of this is going to be vanilla USD code. The only thing that I'm going to do that's Omniverse specific here is I'm just going to get the current stage. Whoops. The get context, get stage. All right. So if you're working in a purely vanilla USD context, you'd probably do something like this to start out and open a stage or create a new stage. But since I want to work in Omniverse with whatever is open right now, that's what I'm doing. So here we go. We got our stage, and let's create a prim here. What are we going to do? We'll create a cube. So I want to create something from scratch so that we can also do a geometric variant. This plane is cool. So this is just 4 points. We can do that. Another day I want to run through USD meshes and talk about all the things about USD meshes and how you can create meshes. So we're going to do a little bit of mesh creation here. And so we can you can gloss over it a bit if you want. Later, we'll have a more in-depth one in the future. Okay, I don't want to get too in the weeds with this one, but let's do it. So is equal to USD. I need to import some Pixar libraries now. Okay. USD geom dot define. Okay, mesh. And we're gonna pass in the stage and that world. Okay, we'll delete this one. We can capitalize it. Run that code. And now we have a plane. Ours doesn't have anything in it, and that's okay. See, so these arrays are empty. So we'll go ahead and do that now. I'm going to create this one just as a reference so that I don't have to do the math and figure or, go through the mental practice of remembering how to build a plane. So, but we can talk about what these are doing here. Copy that. Sweet. Yes. Excellent. Okay, so those are our points, right? So I looked at where did I get this from? I got this from the points attribute. So we need to create that attribute for our plane. So we're going to do plane dot create points pattern. And let me pull up some documentation here so that I'm not just making all this stuff up. And in fact, something that will help us here is if I do USD geom.mesh here for the type hinting. Now Is it because this is on the same line and it's conflicting? No, my type hinting just doesn't want to play nice today. Okay, no problem. We'll just pull up the documentation. All right, so we want to create points adder. So that's actually going to be inherited from, we're in USD Geom mesh. It's actually an attribute and function and an API that's inherited from point based. And we can see that here. So I want to create points adder, and we just give it, I think we can give it the value, the default value there. Yeah. We'll do it this way. Create points adder. So we've created the attribute. That's going to return a USD attribute, so then I can do set. And then I can set this array. All right. So there's our points. Is that enough to get something visualized? Probably not. Why? Because we need a couple more things here. Mesh also needs the indices for when I'm constructing faces, which vertices are the ones that that make up a face, and also how many verts per face. So this is an array defining from this array of indices, um, how many of the items from that list make up a face. So in this case, it's only one face. It has 4 points. So I would just grab the first 4 elements, and that would be my face. But if I had 2 elements here in the counts, 4 and 3, I would grab the first 4 for the first face, and then the next 3 for the next face, and that would, and we'll build that out. I think we'll be able to do a nice example there. So here we're going to create an attribute called, let's look at the documentation. We did points. Now we need to come over here and do face vertex count attribute and face vertex indices attribute. So let's do counts first. Create face vertex counts attribute. And this one's just going to be an array with 1 number. And face vertex indices. I think it goes 0, 3, 2, 1. 0, 2, 3, and 1. That, and now we should get something drawn. Look at that. So what did this do? This grabbed, if we were to imagine that my screen is a plane on X and Y, and Z is pointing out towards me, it's grabbing the bottom left corner for the first point. Then it's grabbing 2 would be this one. Then it's grabbing top left corner for the next one. Then 3 would be top right, and then the last one would be this point. So that's how it drew the face. That's how it constructed it. So nothing too complicated. It is a little bit to think through, but the concepts are easy. And then we're not going to mess with normals. I don't need that really. But there is the normals. We could do extent just to be good citizens. So extent just says is just extra data about um, what is the full bounding box of this mesh. So let's go ahead and can I copy? I can't copy that one. Okay, fine. But that's an easy one. Okay, so let's go check extent here. And extent is going to come from another class called geomboundable, I believe. Nope. Where is that one? That's going to compute it, but it's not going to let me set it. Oh, it's going to be over here. Sorry, that was static. So here we can create extent attribute. All right, and so the mesh inherits from that, so we have access to that directly. So create extent attribute, and then same idea, we just give it the array to set the value. Plain create extent adder set array -50 0 50 50 0 50. All right, and that should be all set now. Okay, so normals are automatically calculated if I don't set it. So because of the winding order of my face, remember that I said that it's winding in this clockwise direction because it started from the bottom left, up, right, down, left. That's how it figured out where the normal needs to be. Cool. For the face normal, at least. So we got that. We're done with this. Okay, so now let's do some variations here. We're gonna do our shading variant as per the tutorial. But we'll just do it with the snippets because we can figure this out. So we're gonna create a variant set. Actually, this is a fairly complete example. We need to get the prim object. Right now we have a mesh. So the way that we do that is we just say prim is equal to plain dot get prim. So every one of these USD schema classes will have a get prim so that you can get the generic prim and do work with that. So variant sets are set on that generic object. I think this is great. We'll do shading variant and variant set, and we'll do those colors, and then so we're getting the variant sets. It's going to be an empty set for now because we were creating this fresh. But if it had variant sets authored, we would add a new one. And so in this case, we're adding this variant set called shading. So you can think of a variant set as a container for variants, right? So you want to generally define a variant set as something that's that you have that's common between those variants. So in this case, we're only doing shading variants. We're only changing the colors. So I'm naming this variant set, the container of variants, shading. And then for each variant that I've defined here, these are just strings. We're going to add a variant with just that string name. So we can run that. Yeah, we can just do it. There's our plane. And now Variants are metadata. Right now in Omniverse, they're showing up in this property panel, but they should be showing up in say, a metadata panel in the future. But here we can see that we did define a shading variant set and our 3 variants. They don't do anything yet. And in fact, let's look at the USDA to see what we've done so far. So here's our plane, and here's the metadata. You can tell that it's metadata because it's in between these parentheses. And we've defined that there is a variant set called shading. It's actually a list. Variant sets are, like I said, you can have many variant sets on a prim, and so it's a list. And so here it's prepending, but since there's only one, it's just prepending shading and the one item. And we're defining a default selection for our variant set. Default is going to be red, or the active selection. And then in here, this is our plane. We haven't, this is outside of the variant set. And here we have our shading variant set, and we're defining these are the descriptions of those variant sets, which are empty right now. Okay. Let me know if you have any questions. We'll finish editing that. And we'll come back over here. So far, so good. Now, we're going to go through each of those variants, and we're going to select the variant, and then we're going to do something in the context of that variant. And then finally, we're going to select the last one. So to improve this a bit, let's make this a dictionary. Red is equal to, oops, no. I know how to make dictionaries. It's going to be a tuple 1, 0, 0. Red, blue. Okay. And so now when we loop through these, this is right. I always get tripped up on Python 2 versus 3 and whether it's looping on the keys. I think it does loop on the keys by default. I guess we can just run it and find out. Delete that plane. Oop, key error. Line 34. I'm not even there yet. Okay, so I think that worked at least. We got the shading variant in there. And we've got the colors in there, so that's good. So now, let's go ahead and we'll adjust this to the first key. I need to convert this into a list before I can do this. And then for variant name and variants, we select it and then we do work here. So now we're going to do so we have our plane. And so generally when we're talking about shading variants, you'd probably make a change on the material. In this case, just for simplicity, I'm going to just change the is that property here. Yes. Okay, we're going to change the prim var display color, and that will give us the color variation. So I could use the primvars API, or I can just use get attribute. So I'm going to copy. Does that work? What did I prim dot get attribute, and then set it to variant name. They'll give us the level. And I suppose it needs to be an array, right? The is here. Where was I? This is an array of colors. So an array of tuples with 3 components. There we go. We got red. So why do we have red? Because I actually ran the whole thing here, and it selected red at the end. It selected the 0th key. So now if we go to our shading variant, we have red. Oh, whoops. Green and blue. Nobody told me that I mixed these up. All right, we got this. Delete that and run it again. Red, blue, green. And if we edit this, we can see here that we're doing, all we're doing is we're, within this mesh, we're defining this attribute now. We're setting this attribute. So there's no display color defined other than the fallback, which is none, the default. So the shading variant is setting it. What happens if I set display color outside of the variant in this example? Does anybody want to take a guess? So we're going to come over here. And we're going to define this out here. And we'll do it definitely won't be in the variant. Good call. What's going to happen to my variant set? Delete this and we'll run it again. So this is the yellow that I set, right? All red, all green, and no blue. So that's coming through. Now what happens with my variant set? It doesn't do anything. Why not? So the reason for this is liver peas. It's the composition arc strength order. Local, inherits, variant sets, references, payloads, specializes. What I've done here is I've set a local opinion for the color. And that local opinion is going to be stronger than anything the variance set says about this particular attribute. Does that make sense? So now you're thinking, well, what if I want a fallback value? Because you could make no selection here. And I commented this out so the yellow went away. But you could make no selection on the variant set, and potentially you wanna use that fallback color, but you want to also be able to change the variance. This is where this is where you need to think about how you're defining how you're structuring your assets for this. So typically, if I were to create an asset, I would potentially have the plane payloaded in or referenced in, and I would and then I would make uh, my variant selection after the fact. So let's see. Should we do that, or should we go to the geometric variant first? Well, I should just we can just delete this here now. Let's run through a few more examples of this, and then we'll talk about how to properly or some potential ways to structure your assets to properly leverage variance sets and not get in your way when you're doing this. So for now, we'll just say, be careful with this, right? Don't have a fallback in that way. Maybe you have a variant called default, right? That would be one solution. And then we'll talk about composition art, and we'll look at the examples of an example of of an asset structure where I could leverage where I can have that functionality that I'm looking for. Okay, so we'll get rid of this. I'll comment it out. And now we'll run this again. Okay, so if I have there's still the no selection. There's green, there's red, blue. I'm not sure what happened with default. Oh, I said it's white. My bad. There we go. Okay, so that would be one solution. Don't you crash on me. I didn't do anything crazy. I think I'm just hanging. Like VS Code's even hanging. Keep wait. It's VS Code. VS Code's the reason. Okay, I think we're good. Yeah. VS Code was the one that was hogging my resources. All right, so we have default, blue, green, and red. Great. Now, let's do a couple more, at least one more variant set. and then we'll talk about some asset structuring. Asset structuring maybe we'll get to in another live stream since it looks like we won't have time. But let's talk about geometric variance set and um, let's see here. This is our hopefully we can do all of this. I'm going to structure this just a little bit different, just so that we can see a little bit more here. We're going to define X form, call this plane. Yeah. This form. Okay, so we define the X form, we define the plane, and then we do all our business there. And then I'm going to define the variance set on the X form, okay? Instead of the plane. I'm going to show you right now when we looked at this. So it's a little hard to see what's going on in here because I've done this all on one prim. So I wanna split this up a little bit so we can illustrate this a little bit better. So we're gonna and I'll delete the plane. And now let's do it. No. Yes, right. Okay, so we have the X form. We're going to form prim. We're going to get both of these prims here. We're going to create the variance set on the X form prim. And we're going to override the display color on this one, on the plane. The rain in Spain. Okay, so now we have two prims, and the variance set is on this one, and then the display color is on its child mesh. And this is more realistic of what you would have in a proper model, a proper asset, right? You'd probably have multiple meshes, or you'd have it'd be more than just one prim. So let's take a look at what this looks like. So now the variance set metadata is on my plane. Mesh doesn't have anything anymore. And the variance sets are still defined, or are defined on the X form, right? The curly braces start for the plane start and end here. So the variance set is outside of that. It's actually within the my plane. But now let's look at how these variants are defined. Instead of just having that one override on the display color, which wasn't even an override, it was directly defined on the mesh because we were defining the mesh for the first time all in that one context. Now we have an over specifier on the plane. The mesh is fully defined here. And then in the variant set, we're saying, oh, but also now we're going to override your child. My plane, we're overriding your child, the one called plane, and we're setting these display colors. Okay, so subtle difference, but I wanted to illustrate that. Now we're seeing this over specifier where we've defined a plane outside of the variant set, and now we're adding override opinions to change the color. Now let's go to our next example. That was shading. Now we're going to do geometry. Okay, and variant sets can be anything. I'm just going with, you could do any sort of variant sets. I'm just going by um, how we've done it in film and animation, where these are the most common variant sets. You would have, for example, a character, and maybe in one sequence they're wearing blue pants, in another sequence they're wearing red pants, or maybe in one a better example, in one sequence they're using their default outfit. Shrek is wearing his default outfit. In another in another sequence, he falls in the water, and so all of his default clothing, the outfit that we know Shrek for, is now wet. So we need to change the materials and make them wet. And so you would do that with a shading variant for that sequence when he's in the water. And then geometry variant could be, okay, well, in this sequence, Shrek loses his vest, or whatever that garment is. So we're going to define Shrek, but in this variant, deactivate the that vest, and so that would be a variant called Shrek no vest or whatever. So that's what we're going to do here. We're going to simulate that here with this geometry variant. So we have this is our default, right? And here we're going to run into the same thing. Well, we need to manipulate these points here. So we're going to have to not define any points until I show you how to sort that out in the future. And instead define it on a default. And we'll do minutes. All right. We're gonna do the whole thing here. We're gonna do points, indices, and counts. So I guess we're not doing any of these here. And I'm gonna leave off. I don't wanna it's just gonna be more work. It's not hard to do. It's just something that doesn't really contribute to this example right now. Okay, right. So let's go ahead and edit this now. And I'll come back and define these other variants, but I just want to make sure that we set these properly here. In the last example, I used the generic print for the plane to set the attributes, but there's no reason why I can use the actual USD geom object to also set these attributes. So now I want to do, and I'm reusing this variable for this script. That's okay. I think, yeah, that'll be okay. Variant name, and then from the variant, we're going to grab points. And then here, we're going to grab counts, and then lastly, indices. So same thing we did up above. Now I'm just grabbing them from this dictionary. And so now I need to do the same thing for my new variants, which are going to be sloped and sloped is going to just be exactly the same, but the top ones are going to be elevated 50. Okay, so so it's going to slope down. So if it's my screen again, these top ones are going to be elevated, and it's going to slope down to the other side. So we're good there. And then for stacked, define two. So we're going to define two planes that are stacked together. So we're going to do that. And these are going to be identical, but they're going to be offset on the z by 50. Or actually, maybe let's do 10. Offset by 10. I think 10 is going to be a better. Well, this one will be 20 instead. A little bit more visual slope there. So now we just need to update these two, right? And in fact, what if we make the top one a triangle, just so that you can see the difference between the two? So this one's only going to have 3 points, and this one's going to be a count of 3. And we're going to do and this is where I messed up. Let me think through it for a sec. The triangle that I want to build is 0, 2, and 3, but it elevated a bit. So we'll do, this would be 0, 2, and 3. So the one that we don't need is this one. So now I can list them in order. I'm sorry if this was a little bit me in my head too much here, but this would be 4, 5, and 6. 4, 5, and 6. And nobody needs to actually build meshes this way. This is just the quickest way to write this without reading data from another file. Okay, I think we're good. So run this. Let's get rid of our plane and my plane. There, look at that. Here's our plane. And whoa, I messed that up for sure. And there's stacked. So I didn't update the vertical on that. But there's our triangle just a little bit above. So we're close, and there's our default. So what did I mess up here? I definitely messed up this, right? Because if I wanted the two top ones, the way that I looked at this is the two top points would be 2 and 3. So actually, these two are the ones that need the elevation. That's fixed. And then over here, I should have reset this back to 0. And this one, yeah, this one's fine. So now that should be better. There we go. Look at that slope. And then stacked. Cool. So now we have our geometry variants, and those work with the shading variants because we're changing two completely separate, and we're overwriting two different attributes with these. So they don't conflict. They, I've defined, instead of having to define 9 different variations, because how many did I do here? It'd be 6 different variations. I've just defined the 3 and the 2, and then I can combine them. And my math is probably off. But so that's nice. Let's take a look at what the USDA looks like. I have 5 minutes to show the last example, but here's our overrides for the colors, and then here's our overrides for the geometry. Okay, and again, I didn't define these. I removed these from the default definition of the mesh because I didn't want to have that that composition art conflicting or stomping on what I wanted to do with my variant set. Next time we'll talk about how to structure our asset to work around that in a better way. Lastly, all of those were overrides, but there's nothing stopping me from even defining new prims in a variant set. So that was geometry. This one's going to be called, I don't know, defining variant set. And I don't even think I need this dictionary for this one. To keep that pattern from before. What can we do here? That will be quick. We'll add some spheres just to wrap this up here. So we're in our variants, and we're going to do, we have our X form prim here, so we can do for X in range variants variant name. That's going to give us the number. We're going to going to then USD geom sphere fine form prim dot get path dot end path f sphere x. Okay. And I'm not even going to scale them or anything. Let me get this out the door and then we'll smooth it out. Oh, I forgot to give it a stage. Fine. Wants, I'm sorry, a stage goes first. And then the path. There we go. So there's our tiny little spheres. And right now, the plane has one sphere defined, which is fine. But now if I switch over to spheres 3, we get 3 spheres. Spheres 2 gives us 2 spheres. And let's look at the USDA to see what that looks like. So here I'm defining 1, 2, or 3 spheres instead of just overriding. So you can see that there's lots of power in this now. If you define a variant set high up in your hierarchy, well, now that whole hierarchy is your playground. You can override any properties, multiple properties in a single variant set and a single variant. You could define a whole branch of prims if you want. There's nothing stopping you. You do want to just think about what knock-on effects that might have down the pipe. Well, if you're defining if your asset starts with nothing and then your variant sets are introducing all this geometry, you need to make sure that downstream you're letting folks know about what is the extent of this asset if it's adding a bunch of stuff, and maybe growing it from some small thing to from one tree to a whole forest in a variant set. That would be good things to let other people that you're working with know, and also maybe the renderer know, because it might get called. It might that might get called in your pipeline if the variant set is set to just one tree and it's outside of the camera, and you have a process that says get rid of any assets that are outside of the camera. But then for that purpose, you actually wanted to switch it to the forest. Well, at that point, it's too late. When you turn on the forest, you've already gotten rid of that asset. I hope that makes sense. But yeah, you just have to keep in mind that with great power comes great responsibility. Any questions? Okay, so next week, I think next week we'll look at how to structure our assets a little bit better to make it easier to work with variant sets, but also having a default value for, or a default setup for our asset that variants can then just build upon, instead of having this default variant for all of our variant sets. That's not very nice, having to go default, default, default. Very cool. All right. If there are no further questions, I will leave you, and I hope you have a great week. And check out our other live streams and events. Let me share a link with you. There's our calendar with all of our events. We have Magiscan coming online for Wednesday to talk about the 3D scanning app, which is pretty nifty. Isaac Sim is coming on Wednesday as well. I'm sorry, that's I believe that's actually learn with me on Wednesday. And engineering design in Omniverse on Thursday, and we'll have office hour on Friday. I need to get that on the calendar. And that's it. I will see you around. Have a good week. Bye.